The next type of instructions are branch group. The branch group. So the first one instruction here, it is jump 8-bit or 16-bit address. It's also called as unconditional jump. The jump instruction specifies by the address. For example, jump 2000. So that means here jump, the microprocessor is going to jump the control from the where it is executing there to the address what you're going to specify in the instruction. For example, jump 2000 means the control will jump to the address 2000.
So here I am taking one example here, JMP 2000. So you can see I have taken a small program. So in this I am not giving any condition, that means I am giving an instruction called as JMP 2000. So I am not providing any condition. Since I am not providing any condition, so it's when the microprocessor executes JMP instruction without condition, it is going to directly jump to the address which is mentioned in the instruction. Here I am taking example JMP 2000. When processor executes this instruction, immediately it is going to execute to the immediately it is going to jump to the address which is specified in the instruction, that is 2000H. Conditional jump instruction. So here program sequence is transferred to the memory location specified by 16-bit address based on a specific flag which are mentioned in the flag register, or also it is called as program status word, so which is shown below. So we all know that this program status word or flag register, which consists of 7 flags starting with a D0. D0 stands for here carry bit. So we can provide a jump instruction when carry is set and when carry is reset. And similarly D2 bit we have, it is a parity bit. So parity means if number of ones are even, then parity bit is going to set. Then we can provide a condition jump instruction called as JP, and similarly jump on no parity. And similarly we have Z stands for 0. I can provide instruction JZ when there is a 0 condition exists. Similarly, when there is a negative number, then I can provide a condition jump on negative and jump on non-negative.
The first one is JZ, stands for jump if the result is 0 or 0 flag is set. For example, if I give JZ label, so that means label is the address what we are going to specify in the instruction. It may be the 8-bit address or maybe 16-bit address. For example, here I am considering label is equal to 3000. So when the instruction JZ label executes, the control is going to jump to the address memory location with a 3000H.
Yes, here I am taking one example and small program I am considering here. We can see in the diagram we have taken one small instruction JZ. So that means, and also we are considering here 2 operands A and B. A I am loading value 12 and B also I am loading 12. You can see move I stands for MVI stands for move immediate data A with a 12, move immediate data B with 12. So then after that when I subtract A comma B, that means A minus B, 12 minus 12 is 0. So that means here I am getting 0. So now I can give a instruction as a JZ, that means jump if 0 flag is set. So when the result you are getting 0, then 0 flag is going to set. When this condition exists, I can provide instruction JZ. When I give a JZ, control is going to pass to the mentioned address. So here I am giving JZ 3000. When this condition exists, control is going to move to the 3000H.
Similarly, we have one more instruction called as JNZ, stands for jump on non-zero, or if 0 flag is not set. So example, I can give JNZ to label 2. So that means if 0 flag is not set, it has to jump to the label 2. What is this label 2? This label 2 is nothing but address what you are going to specify in the instruction. For example, here I am taking 4000, 16-bit address I am taking. So when the microprocessor executes this instruction, the control will jump to the address 4000H.
So here also I am taking one example, for a jump on non-zero condition. So here I am loading accumulator with a 15 and B register with a 12. So when I subtract A minus B, you can see here in the program, small program, I am using sub A comma B, stands for subtract A comma B. When I subtract A minus B, 15 minus 12 is 3. This is a non-zero, this is not a zero condition. When my zero flag is not setting, or when I am getting non-zero result, then I can use this instruction as a jump on non-zero. Here in the example, I am giving JNZ 4000. When I get a non-zero result, this instruction is going to execute JNZ 4000. When I give this instruction, it is going to move to the 4000 memory location, and it is going to continue its execution from move A comma FF.
Similarly, we have next instruction called as JC, stands for jump if carry flag is set. Here also same thing, the label we have to specify either in the form of label or in the form of address we have to specify. If carry flag is set, the control is going to jump to the address what you are going to specify in the instruction. Here I am considering JC label. JC label, the label is address having 5000. So when it executes this instruction JC label, it is going to jump to the memory location 5000H.
For JC also, here we are taking one example. In the program, small program, we are taking accumulator with F2 and B register I am taking with a 12. When I add these two, you can see here I am using add here. When I add these two, F2 plus 1 2, when I use this, I am going to get sum as a 104. In that, sum will be 04 and carry which is going to generate as 1. F2 plus 1 2 is 104, sum is 04 and carry is 1. So here it is generating a carry. When the carry is generating, then we can use JC instruction. JC instruction stands for jump on carry. When I give JC 5000, carry flag is set, then this processor is going to move, control is going to move to the instruction address which is specified in the instruction. Here it is 5000H.
Similarly, we have JNC, stands for jump if carry flag is not set. JNC stands for jump to the address if carry flag is not set. So this I can give example JNC label. Here also the label is 5000. If carry flag is not set, control is going to move to the address 5000H.
And for JNC also, I have taken one example here. Move accumulator with the 92 and move B register with the 12. If I add these two, I will be getting summation as a A4H and carry I am not generating. Carry is equal to 0. So that means if the carry is not generated or if carry flag is not set, then I can use this instruction. So I can give here JNC 5000. If carry flag is not set, then jump to the mentioned address. Here it is 5000. Control will move to the 5000H if carry flag is not set. For example, by this time if carry flag is set, then processor is going to execute. This condition is going to fail here, JNC condition is going to fail, then processor is going to move to the next instruction, move B comma C, it is going to execute.